Now we're going to work on solutions and mixtures. We're still using equations to solve word problems. If you were given a 40% solution of alcohol and a 60% solution of alcohol, and we were told we wanted 100 liters of 48% alcohol, we would need to set it up using some variables. So the question is, how much of each solution is required to make a 100-liter solution of 48% alcohol? So here are variables. Let X represent the 40% alcohol solution and let Y represent the 60% alcohol solution. I can also put this into a table where I've got the solution X, solution Y. The amounts are X and Y. The total is 100. And then what I have here is percentage per amount, 0.40 times X, because every amount of X is 40%, every amount of Y is 60%, and we want 100 liters of the amount at 48%. If you look at this, you can see that right away I've got my two equations right here. And what I mean by that is that I can rewrite these equations now and say, basically, X plus Y is equal to 100. That's one of my equations. And the other equation is 0.40X plus 0.60Y is equal to 0.48 times 100, which is 48. And there you can see that I have both equations. And now I can start solving the system of equations. And this is the same as you do with all the other systems. If it's decimals, we can get rid of the decimals and we can do that. So let me rewrite these equations for you. We have X plus Y is equal to 100, 0.40X plus 0.60Y is equal to 48. And if you choose to eliminate the decimals, we can multiply this equation by 100. And so we have 40X plus 60Y is equal to 4800. We can use substitution. That could be the easiest one, and put X is equal to 100 minus Y. I can plug that into here. 100 minus Y for the X plus 60Y is equal to 4800. Do all the math. Use distributive property. And here we have 4,000 minus 40y plus 60y is equal to 4,800. I can simplify here and have 20y, bring that over to the other side, 4,800 minus 4,000. And so 20y is equal to 800. And divide both by 20. Y is equal to 40. And now that we know that Y is equal to 40, because X is equal to 100 minus Y, which we have up here, we now know that X is equal to 60. And there you have it. There's the equation solved. The variables have been solved. So we would need 60 liters of the 40% and 40 liters of the 60% in order to create our 48% solution of 100 liters. Okay, and that's for solutions and mixtures. The next one is about mixtures. The first we did is solutions, and this is very similar. So here we have a department store manager who decides to mix cashews and pecans to get 400 kilograms of nuts that would sell for $10.08 per kilogram. If cashews sell for $9.60 per kilogram and pecans for $10.80 per kilogram, how many kilograms of each must she use? So let X represent the kilograms of cashews. Let Y represent the kilograms of pecans. And so we know the total of the cashews plus the pecans. We want to create a mixture of 400 kilograms. For every X, for every amount that we put here, it's worth $9.60 a kilogram. So we'll put 9.60 for every cashew. And then for every pecan, it is worth 10.80 y for everyone. And in total, for every 400, what do we want? Well, we want to sell it at 10.08 per 400. Now, again, in this case, we can use, we can multiply this whole thing by 100 to eliminate the decimals. So 960x plus 1080y is equal to, if you calculate all this, you get this number, 403,200. And so now what we want to do is figure out how we're going to solve this. We have elimination, substitution. I would take substitution and make x here equal to 400 minus y. Now once you've done that, you can plug this x here. We can plug that into here. And so I've done that for you over here. And there you have it. We've got 9.6x plus 1080. We've converted it by multiplying by 100. We then plugged in what the x value is using substitution and then figured it out. We got y, which was our pecans. We need 160 kilograms. And for the x, if you subtract 400 from 160, you get 240. And therefore, we would need 240 kilograms of cashews and 180 kilograms of pecans. And this is how you would create the situation where you have mixtures and you want to mix a certain amount in one and a certain amount in the other, and your total was 400, and you wanted to get this final price per kilogram, and this is how you would do it. And this is how you do mixtures. The next word problems deals with time, distance, and speed. The one thing we need to remember is the relationship between distance, time, and speed. Distance is equal to time times speed. Speed is distance over time, and distance time times speed. So you can use this little triangle to remind you of the relationship between distance, time, and speed. In this question, we're talking about how it took Ed 8 hours to row 40 kilometers upstream. The return trip with the aid of the current took 5 hours. Find the speed of the current. In this case, we have the current working with him and the current working against him. So we need to write two equations so that we can figure out the speed of the canoe and the speed of the current. If we let B represent the speed of the canoe and let C represent the speed of the current, it took Ed 4 hours to row 40 kilometers upstream. The return trip with the aid of the current took 5 hours. So if we have let B represent the speed of the canoe and let C represent the speed of the current, what we have is the boat upstream is minus the current is equal to, well, let's look at this. We have 40 kilometers and it took 8 hours. And if you look at this relationship, speed is distance over time, which is what we did here. And what you can see that was 5 kilometers an hour. So we can put 5. With the aid of the current, it took 5 hours. So now the current is helpful. And let's just put here, the distance is still the same. The time is reduced. And so you've got 40 over 5 is 8 kilometers an hour. And we can put 8 over here. And then by doing this, and now what we have is B minus C equals 5 and B plus C equals 8. And we can use elimination and we can subtract. And if I subtract, these get eliminated. I've got negative 2C is equal to negative 3. Divide both by negative 2. C is equal to 1.5. And therefore, the current speed is 1.5 kilometers an hour. And if I wanted to find out what the speed of the canoe was, I can take this c and plug it into here or into here. And if I did that, I've got b minus c is equal to 5, b minus 1.5 equals 5, and so b minus c is equal to 5, and we've got 1.5, negative 1.5, and bring it over here, and you've got b is equal to 6.5. And so the speed of the canoe is 6.5 kilometers per hour. And you can do this with any question that has to do with, let's say, either current that's with or against a canoe, wind that is with or against a plane. And this is how you can set it up, where you find out what the speeds are with the current or with the wind, and what it is with or against it, and then you can figure it out this way. And that's how you do the speed, time, distance questions.